Hello, Econ 150 students. This week, we're in our week 10 homework, we're looking at perfect competition or pure competition. So these homework questions are going to be related to that model. Last week, you looked at the cost curves for a firm, and so now we're going to look at different firm structures, and I've provided some helpful resources to kind of guide you in your understanding of what different firm structures are. And now we're going to focus on the first one, the most competitive structure, which we refer to as pure competition or perfect competition. So this first question says a purely competitive firm that finds that the market price for its product is $20. Now, before we go too much further, what you probably remember from your reading is that the market price is the firm's price. If they are a purely competitive firm, they are a price taker, which means they take their price for the market. So if the market looks like our competitive markets that we've been evaluating so far, and that is the market price determined by the interaction of supply and demand, then the firm, if we put it next to it, takes that price, and their marginal revenue curve becomes the market price. So they are price takers. So that'll help us as we evaluate this. And it tells us that the market price is $20 for our firm. It has a fixed cost of $100 and a variable cost of $10 per unit for the first 50 units and $25 per unit for all successive units. So we're asked, does the price equal or exceed average variable cost for the first 50 units? So we have right here, very easy answer. The price is $20 and the average variable cost is given to us as $10. And so the answer there is yes because of that. The first 100 units, we can also say that the answer is yes because $20 in price also exceeds the average variable cost. And the way we calculate that is by taking the average variable cost of the first 50 units, right? Average variable cost of 50 units is $10. And the average variable cost of the remaining units is $25. So that's units 51 through 100. And if we put those together, we say 10 plus 25, take the average of that divided by 2, and we get $17.50 a unit. So the answer here is yes, because $20 is still more than the average of those two portions of production. B says, what is the marginal cost for this first 50 units? And how much is that per unit? And we've already given that information, been given that information. That's $10 per unit. The marginal cost, the additional cost is over and above. The previous is $10 per unit. The marginal cost for units 51 and higher, $25. That was given to us. For each of the first 50 units, does marginal revenue exceed marginal cost? Well, marginal revenue, as we said, is that price that the firm takes from the market. So our marginal revenue here is $20, right? So for the first 50 units, well, $20 exceeds that marginal cost of $10. So does MR exceed MC for the first one? That's a yes. And for units 51 and higher, the marginal cost is $25, and the marginal revenue is only $20. So I've written it backwards here, but hopefully you can see this, and the answer is no. And D, what output level will yield the largest possible profit for this purely competitive firm? And for this, that output level is 50 units because by definition, profit maximizing means we produce until the point that marginal revenue is equal to marginal cost. And at the units 1 through 50, marginal revenue, 20, is greater than that marginal cost. However, at 51 units, that marginal cost exceeds the marginal revenue. Therefore, we would stop at 50 units. So the profit maximizing output is where marginal revenue is equal to marginal cost, and that is at 50 units. For number 2, I realize that sometimes we get different versions of this, so what I'm going to go over may not match, in fact, it does not match what's on the homework answer sheet that I gave you, and it may not match what you have, but it should still be instructive in how to come up with the correct answer. So this one tells us that, in this case, a purely competitive wheat farmer can sell any wheat he grows for $30 per bushel, and then he has diminishing returns on his land because some acres are better suited for wheat production than others, but we get the production outputs from the problem here. So the yield for the first acre and so on. If we know that they can sell each bushel for $30, then for that first acre's yield of 1,000 units, and they sell them at $30 each, that revenue would be $30,000. Total revenue for that 1 acre would be $30,000, and marginal revenue, the change from the previous, would be $30,000. We can continue on and calculate the second one, 900 units at $30 per unit, $27,000. Total revenue then becomes $57,000. We add those together. And the marginal revenue is the change between the total revenue, 1 and 2. And so we get $27,000 in marginal revenue. The third one we can do the same way, 800 acres at $30 per bushel, $24,000. Total revenue then is the total, $81,000. And the marginal is that $24,000. It's a little messy here, but hopefully you're following the numbers okay. I'll try to clean it up a little bit. 700, 21,000. The total then is 102,000. And the marginal revenue becomes 21,000, that change. And finally, 6 times 30, 18,000. 120 is our total at that point, and our marginal is the 18,000. So we've got that information, and part B says if the marginal cost of planting and harvesting an acre is $21,000 per acre. For each of the 5 acres, how many acres should the farmer plant and harvest? So if you remember, our profit maximizing output decision is where marginal revenue is equal to marginal cost. And at that point, that's your stopping point. So as long as marginal revenue is greater than marginal cost, you keep going, this firm does. And as long as, if the time comes where marginal cost exceeds marginal revenue, then you should have stopped by then. So this is our calculation or our balancing point for profit maximizing output. How much? And this is a how much decision. So it says how many acres should the farmer plant and harvest at 21,000. So that means our marginal cost is 21,000, and we're just going to find out where marginal revenue exceeds marginal cost without becoming less than. So right here we have a nice clean break where we can see it, and that is going to be right here at 21,000. So in this case, the profit maximizing decision is at 4 acres, where marginal revenue of 21,000 is equal to that marginal cost. Number 3, Karen runs a print shop that makes posters for large companies. It's a very competitive business. The market price is currently $1 per poster, and she has fixed costs of $250. Her variable costs are $1,000 for the first 1,000 posters, $800 for the second 1,000, and then $750 for each additional 1,000. And so we're going to calculate her fixed costs per poster, her average fixed cost. So that's the that asymptote function that we had talked about last chapter. And we'll take it from there. So if she prints 1,000 posters, we're going to take her fixed cost of $250, divide that by the 1,000 posters. That's how we get an average. And we're going to get, we do that, we get 0.25, so 25 cents per poster. If she prints 2,000 posters, we're going to take that same fixed cost, divide that by 2,000, and we're going to get 0.125 or 12.5 cents each. And 10,000 posters, all we're going to do is divide that by 10,000, and we're going to get 0.025, basically adding a 0 to our previous calculation here. So average fixed cost, you'll notice, is constantly approaching 0, but since we define it as an asymptote, it will never actually achieve 0, but will always head towards it. Number 4 gives us some information about a purely competitive producer. And this producer has, we can see output, we can see average, fixed, variable, and total cost, as well as marginal cost. So we're asked to come down here to A, B, and C and evaluate what their decision will be. So at a price of $56, so I want you to remember that marginal cost equal to marginal revenue. That's the profit maximizing output quantity decision, right? So how much should we make? How much should we produce? And the decision is made there. So in this case, marginal cost can be seen in this column, and marginal revenue for situation A would be $56. So marginal revenue, $56. So we can come right here to the column and say, well, marginal revenue exceeds marginal cost still at $55, and you wouldn't produce units 9 or 10 because in those cases the marginal costs exceed the marginal revenues. So you can say right off the bat one thing, and that is that they would produce 8 units if they're producing. Now, the other part of this is the shutdown decision. And the shutdown decision, if you'll recall, is where the marginal revenue is less than the average variable cost. And the logic here is that if you can offset any of your fixed costs, which is the difference between average variable and average total, then you should continue to produce because you're better off offsetting some of your fixed costs than shutting down. If you shut down, you lose everything. All of your fixed costs are gone. However, if you can offset some of them by continuing to produce, staying in business makes sense. So as long as marginal revenue is greater than the average variable, which means that some of those fixed costs are being dealt with or resolved, then you're better off continuing in business. So knowing that, we can come here at 8 units and we can say, well, where's average variable cost? And it is here. So our marginal revenue would be $56. Average variable cost is 40.63. So what that tells us is, yes, you would produce in the short run. You're covering your variable and you're offsetting your fixed, some of them at least. And it says, is it preferable to produce, if it is preferable to produce, what would be the profit maximizing or loss minimizing output? And we just identified the profit maximizing output here at 8 units. And it's profit maximizing. And finally, what economic profit or loss will the firm realize per unit of output? So it's pretty easy to see if we can say, well, the marginal revenue per unit is $56, and the average total cost is $48.13, then you're going to have a profit of $7.87 per unit. So that's where we got that value. And we can continue on and do the same thing for the other calculations here. We'll go to another one. At a price of $41. So again, marginal revenue is $41. So how many units would we produce? Well, we'd have 6 units. We want to double check, make sure that that $41 is above covering our average variable cost. It is. So in this one, it'd be a yes. How many units of output? 6 units of output. And would this be profit maximizing or loss minimizing? So $41. Sorry about that, I'm reading this carefully. Now in this case, we can look at the profit per unit and what's going on here. So it's not always a profit maximizing situation. It could be that if you're offsetting your variable costs, you are still earning an economic loss. However, it's still better to sustain that loss than to shut down altogether. Again, for the same logic as before, that if you shut down, you give up all of your fixed costs. If you continue to operate even at a loss in the short run, while you're covering your average variable costs, and then some of your fixed costs, you're better off. So here, with $41 being the price of the product, and the average total cost being $47.50, we'd have a loss of, in this case, $6.50 per unit. So it's still a good idea to continue operating. However, it is a loss minimizing output decision. So let me see if I can make that work. Loss minimizing. And the loss per unit then is $6.50. Now at $32, we can come over here and let's say marginal revenue is only $32 per unit. And let's say here's our point where the revenue is still greater than the cost. And could we do this? Well, here's average variable cost, $37.50. So would we continue to produce? And in this case, we'd say no, because that marginal revenue of $32.50 is below average variable cost. So that's our shutdown rule. Let me try a different color here, see if it's easier to see. So it goes against our shutdown rule. So the answer here is no. If we can't offset any of our fixed costs and we can't cover our variables, then it's far better to shut down and walk away. So in this case, we're not going to continue to produce, and so the output, of course, is not applicable here. And the total loss here would be what we're calculating. So there's no per unit loss. There'd be a total loss in this case of $60 because we're giving up all of our ability to produce. We're shutting down. And the $60, by the way, came from the fixed cost, the total fixed cost. So for that first unit, we know that that's total fixed cost because for one unit, the fixed cost is $60. So that's the loss, is all of the fixed cost there. Then it goes on to give us another portion. It says D, in the table below, complete the short-run supply schedule for the firm and indicate the profit or loss incurred at each output in column 3. So and this is just asking us to recognize where that short-run supply curve is for the perfectly competitive firm. For this next part, we're asked to go back through that information and calculate for each individual firm what production would occur at different prices and whether that indicated a profit or loss. And then we're going to aggregate it to 1,500 firms and see what that means. So let's do the first one together. At a price of $26, now we just finished saying that at a price of $32, nobody would be in the market because there's no $32 doesn't cover the average variable cost. So here we can say, well, at $26, nothing is produced, and the loss here is going to be that total loss that we said before, the shutdown loss of all fixed costs. So it's going to be minus 60. And that's not going to be an amount produced by any of the firms. So all 1,500 firms together, nothing will be produced. The second one, the 32, we've already covered that, and we have the same scenario here. It's going to be a shutdown, total loss, none of the 1,500 firms. Now at 38, we can come here, and remember 38 represents marginal revenue, so we could say, well, 38 is, we wouldn't produce 6 units, but we would produce 5 units because our revenues cover our costs at that point. We can come over here, see that the price of $38 covers our average variable cost. So at $38, we would produce 5. And at $38 per unit, minus the $37 in average, $49 in average total cost, $49 in average total cost, is going to be a loss of $55. So it's an 11 per unit. So a $55 loss. And you'll notice that even though it's a loss, it is less than the loss for shutting down. This is why we recommend that firms stay in business if they can offset some of those total costs. And if we extrapolate that out to 1,500 firms, then it becomes the quantity is what's extrapolated out, not the cost. But 7,500 units then are produced by those 1,500 firms. We can do the same thing at 41. And at $41, using all the same processes, 6 units are produced. The profit or loss in this case for those 6 units is $39 total for all 6 units. And the number of units provided to the market is going to be those 6 times 1,500, assuming identical firms, and so 9,000. At $46, 7 units are produced. Again, we can come up here and go through this process here. We can see $46 is more than our average variable cost. So we will be producing those 7 units. And the average total cost, however, is a little bit more. So the loss at $46 is over those 8 units, $8. And the amount produced in the unit in the market is 10,500. And at $56, 8 will be produced. These 8 will produce a total profit of $63. That's because we'll take the total average total cost, subtract that from the price per unit, and multiply it by 8. And then the total produced to the marketplace is 8 times 1,500 firms, and that's going to be 12,000. And then finally, at $66, we can see that 9 will be produced. Those 9 will produce a total profit of $144, and it will cost $13,500 to be produced in the marketplace of 1,500 firms. And the last part, E, says now assume that there are 1,500 identical firms in this industry. That is, there are 1,500 firms, each of which has the cost data shown in the table. Complete the industry supply schedule in the table above. So this is asking you to see the supply schedule. And here's the demand information. And so what we're going to do is we're going to create that schedule. Now, it doesn't ask you to do it for points, but it's not a bad idea to just see that you've got your price and your quantity supplied, right? So you can just pull that information. Price and quantity supplied, this is to the market. And I'm just going to do a real rough job here, but you can see at a price of, let's start with the what's going to be produced. So let's go 38, 7,500, 41, 46, 56, 66. Those are the prices, and the quantities that prevail then are 9,000. Forgive the sloppiness here. 12,000 and 13,500. So now that you've got a supply schedule, and note the rule here is for the firm, the competitive firm, the supply curve for the firm is the short run supply curve, I should say, is the marginal cost curve above average variable cost. That's the rule. So the supply curve for firm, just to draw it out for you here, is if we have marginal cost and we have average variable cost, we'll call this, because remember that's the shutdown rule. Minimum average variable cost is anything below that's the shutdown rule. So this range right here of the marginal cost curve represents the incentives for the producer. So this is going to be the supply curve for the firm that they observe. So the demand curve they have is that perfectly flat marginal revenue curve. That's their demand. And their supply curve is this. And so they're going to be producing at that marginal cost equal to demand. That's the output level. That's MR equals MC. All those things we've talked about before can be seen graphically and observed here. So let's go back to this. And suppose the market demand data is given to us here. And the question becomes, what is equilibrium price? Well, equilibrium is where quantity supplied is equal to quantity demanded. So here we're asked to find the equilibrium price. And what we can see is it's where price and quantity supplied and quantity demanded are equal at a particular price. So what we can see here pretty quickly is that at $46, 10,500 and $46, 10,500. So our equilibrium price is $46. The equilibrium output is 10,500 units. And for each firm, we would just take that 10,500, divide it by 1,500. I did that backwards, don't mind me. Divided by 10,500. I can do this. 500 divided by 1,500. And it's going to be, for each firm, oh, I see, it's the output for each firm, is going to be 7 units for each firm. And then it says, what will be the profit or loss per unit? And it's going to be a loss, because we can go back to the information for each firm. And at 7 units, we already calculated this, but the loss is going to be that $46 minus $47.14. So 46 minus 47.14. This is going to be a per unit loss of $1.14. And it goes right here. So it's going to be a loss of $1.14. And then the firm, take that $1.14 times 7 units that each firm is producing. And for each firm, it's going to be $7.98. So this one's a kind of all over the place, but all the parts come together, and the key is to just keep connected between the information that's given to you and then all of the understanding, the shutdown rule and the understanding of marginal cost equal to marginal revenue. All of that will help you. Number 5 is a little less intense. It says identify the basic characteristics of the following market models. So this one shouldn't give you too much trouble, because we've been talking a little bit about those things that should have been in your materials for this week. And again, I've provided a short video that kind of goes through the different market structures to help you recognize the different ones. But here we go. In perfect competition, the things that are true are that we've got a very large number of firms with no control over price, and that's all that would be true of that. In pure monopoly, you've got one firm with a unique product and with a great deal of control over price. Monopolistic competition falls in between, and it encompasses both monopoly characteristics and pure competition characteristics. And so you've got differentiated products with many firms, and you've got some price control because they can differentiate, and because of that they can control the price. Think fast food usually comes in this kind of market. Pure monopoly we don't see so much. An oligopoly is between really monopoly and monopolistic competition. It's more competitive than monopoly, but less competitive than monopolistic competition. So oligopoly is a few firms that engage in non-price competition, often because they're selling identical products, and so they have to engage in competition that's not about price, but differentiates the products. And there are many obstacles to entry. So they have some control over price, and there's more than one firm. So these would be your characteristics here. B says, under which of these market classifications does each of the following most accurately fit? And so this is a good chance to kind of see this. A supermarket in your hometown is probably part of a chain, so oligopoly. The steel industry, again, only a few firms that dominate, oligopoly. A Kansas wheat farm products, agricultural products, are almost always considered pure competition, and primarily because of the product itself can't be differentiated. If you think about it, wheat is wheat, and there's no flavors, no brands, no quality differences. It is simply only compared based on price, so that would fall into pure competition. Then the commercial bank in which you and your family have an account is monopolistic competition. has all of those products that are similar but differentiated, and lots of firms. And the automobile industry is a really good example of an oligopoly because there's only a few firms that dominate the industry and they engage in lots of non-price competition. Number 6, consider the statement, even if a firm is losing money, it may be better to stay in business in the short run. And what do we know about this statement? It is true if the loss is less than the fixed costs. So if the loss is less than fixed costs. Now, the shutdown rule is if the price is less than the average variable cost. But to restate that, if the loss is less than the total fixed cost that you give up, then it's better to stay in. So it's two ways of seeing the same thing. B, the firm should produce in the short run as long as the price, now this is the other side of that, as long as the price exceeds the average variable cost. So that's going to be a restatement of what we've said before. Number 7, the equality of marginal revenue and marginal cost is essential for profit maximization in all market structures, because when this is true, so this rule, this MR equals MC rule, is profit maximizing output for all of the market structures, not just perfect competition. And it's true because when it's true, the last unit produced adds more to revenue than to costs. So adds more to revenue. Make sure I'm circling the right one here. Adds more to revenue than to costs, and its production must necessarily increase profits. As long as marginal revenue is positive, it's adding to profits or it's minimizing losses. So this is why we do that. B, when an industry is purely competitive, price can be substituted for marginal revenue in the MR equals MC rule because the demand curve is perfectly elastic and the price is constant regardless of the quantity demanded. So here's our correct answer. So when we draw the firm by itself, independent of the market, we would say that the marginal revenue curve is perfectly elastic. And the idea here is that if price changed, the competitive firm, the perfectly competitive firm, would lose all of its customers to another firm. So there's no benefit in lowering their price, and ideally, using our definition, if they raised price, they would lose all of their customers to the competition because the competition is based purely on price, and the firm has no ability to control the market price. So the demand curve perfectly elastic, and the price is constant, so it doesn't affect output at all. Number 8, use the following demand schedule to determine total revenue and marginal revenue for each of the possible levels of sales. Let's get that. So here we go. We have the product price of $2, and we can say, well, the quantity demanded at $2 is 2, so total revenue there is, let me make this bigger, is 0, and marginal revenue isn't affected. At $2, 1 is demanded, so total revenue is 2. Marginal revenue is the difference in change in total revenue, so it becomes 2. At the price of $2, you've got 2 demanded, so total revenue of $4 and marginal revenue of $2, right? 2 more. And product price of 2 at 3 demanded would give us total revenue of 6, and marginal revenue from 4 to 6 is 2. Total revenue here, 4 demanded at price $2 is $8. Marginal revenue, $2. And finally, 5 units at $2 is $10. Marginal revenue is $2. So it says, what can we conclude from this about the structure of the industry in which this firm is operating? Well, if marginal revenue is always the same, notice that the price is constant, marginal revenue is constant. We just finished drawing a picture of that marginal revenue curve that is constant. This is the price. and it's also the demand curve, and it's also the marginal revenue curve. In fact, some people refer to this curve itself as Mr. DARP to tell the whole story. So Mr. marginal revenue, demand, average revenue, price. So you might hear it referred to that way. It might help you remember all of those things are true about that curve. So what can we conclude about the structure of the industry? And that is that it is purely competitive. So that gives it away, that the marginal revenue and the price are constant, unchanging. So this next part says to graph the total revenue and marginal revenue curves for this firm. So we've got the total revenue information at relative to quantity demanded, and we can, there we go. And here is the information we're going to work with for the total revenue. So I can say quantity demanded of 0, total revenue of 0, quantity demanded of 1, total revenue of 2, 2, total revenue of 4, 3, total revenue of 6, 4, total revenue of 8, 5, total revenue of 10. So our total revenue curve, pretty easy to see there. Marginal revenue is going to be equally easy. To graph the marginal revenue, you're just going to put in that straight line at $2 because it doesn't change. So this one, constant, pretty easy to see. So there's your graphing of these two, pretty straightforward, pretty easy to do. The next part of this says, why do the demand and marginal revenue curves have the same shape? So this is asking why this So after we see that flat marginal revenue curve, we're asked, why do the demand and marginal revenue curves have the same shape? And in this case, we've already kind of touched on that, and that is demand is perfectly elastic, marginal revenue is constant and equal to price. So again, it's a little silly, but it might not hurt to keep this in mind, that Mr. DARP notation helps you remember that those all measure the same thing, that those concepts are all the same. And then finally, true or false, marginal revenue is the change in total revenue associated with additional units of output, which is our definition of marginal revenue. So this is true. Number 9, a firm in a purely competitive industry is currently producing 1,000 units per day at a total cost of $450. If the firm produced 800 units per day, its total cost would be $300, and if it produced 500 units per day, its total cost would be $275. So it asks us to do some calculations. It says, what are the firm's average total cost per unit at these levels of production? So we're going to want to find out our total cost, and then we can divide by the number of units to get our average total cost. So total cost at 1,000 units per day is 450. So we're going to take 450, divide it by those 1,000 units, and we get 0.45, so 45 cents per unit. If the firm produced 800 units per day, total cost of 300, so we're going to take that $300, divide by the 800 units, and we get 0.38. And 500 units a day, the total cost, 275. Same thing, we'll do the division and we get 0.55. The question is, if every firm in this industry has the same cost structure, is the industry in long-run competitive equilibrium? So by definition, long-run equilibrium is where the firms are producing at the lowest average total cost. And that would be, in this case, 38 cents. So the answer is no, because this firm in this industry is not producing at the lowest average total cost. That's our definition of long-run equilibrium. From what you know about the firm's cost structures, then, what is the highest possible price per unit that could exist is the market price in long-run equilibrium, and that's going to be what we identified as our minimum, 38 cents. So long-run equilibrium, just to give you a visual of that, is where we've got the firm operating. Here's average total cost, here's marginal cost, and here is price, or Mr. DARP, demand, price, whichever one you want to call it. And that is the output where they're maximizing lowest average total cost, the minimum there. And that long-run equilibrium simply means that there are no profits or losses to either drive firms out or entice firms in, which means that the industry can maintain this for some time because no firms have incentives to leave or enter. So there aren't going to be changes in the market, which means that the firms can continue to produce. Part D of this question, if that price ends up being the market price, and if the normal rate of profit is 10%, then how big will each firm's accounting profit per unit be? And so it's going to be, cents per unit is going to be 3.8, 10% of that 38. Number 10, entry and exit help to improve resource allocation because, and this is about firms entering or exiting the market. One reason that they have that freedom to do so is because of the market structure. So here, losses result in exit and release resources to flow to markets where there are profits. And that's an important thing to know, is that profits or resources follow profits. So the losses in a market structure like this will allow that easy entry and exit, and firms can take their resources elsewhere to markets where profits are possible. Number 11, the equality of marginal revenue and marginal cost is essential for profit maximization in all market structures because, and this appears to be a restatement of the either one, a previous one, but what we know is that marginal revenue and marginal cost are equal, if they're equal rather, then any other output level will reduce profits. So, will result in reduced profits. So here's our answer. I want to make sure I'm circling the right one. Sometimes I don't do that. Yeah, there we go. B, price can be substituted for marginal revenue in the MR equals MC rule when an industry is purely competitive. This is just some definition stuff. Because price is constant regardless of the quantity demanded. So if you go back to the graphical visual of that, remember that price can be substituted for marginal revenue because they're both constant. C, in long-run equilibrium, price equals minimum ATC equals marginal costs. The equality of price and minimum ATC means that the firm is achieving, and this is going to be productive efficiency. This is our definition. Productive efficiency means producing at the lowest possible cost. That's our definition of that, in fact. Now, D takes us to a different place. It says the equality of P and MC means that the firm is achieving, and this one is what we'd call allocative efficiency. Since the industry is producing the amount of product that equates society's value of that product and the price of the product. So this is what we call, oops, I did that with the wrong one. It's allocative efficiency. Since the industry is producing the amount of product that equates society's valuation of that product. And that's what we call allocative efficiency, means satisfying the wants of society. And a little memory device for that one, if you ever have a problem with that, is MC equal to D. I tend to mean that it's, I'm substituting D for P here. And I tend to think of it in terms of like McDonald's being allocatively efficient. It's what people want. 12, suppose that the pen-making industry is perfectly competitive. Also suppose that each current firm and any potential firms that might enter the industry all have identical cost curves with minimum ATC equal to $1.25 per pen. If the market equilibrium price of pens is currently $1.50, what would you expect it to be in the long run? And so remember, minimum ATC is long-run equilibrium, so it's going to be $1.25. Number 13 gives us a chance to see the side-by-side graphs of the industry and the representative firm. And so what we can see, first of all, before we even make any changes, is that the firm is indeed a price taker, which means that they take their price from the market originally. So this is A and this is A. And then the question says, use the diagrams to illustrate competitive long-run equilibrium. And given the change in demand in the diagram on the left, which is that it shifts to the right to show an increase in demand, show how this affects the firm. Well, if the firm is a price taker at equilibrium A, then when that demand increases and the price rises to B, there's going to be a similar effect on the firm, which is they're still a price taker. So that MR curve will shift upward. So in your program there, you can use the tool to shift that curve upward. It should snap into place. Given this change in demand, the representative firm is going to produce, well, MR equals MC. That's our profit maximizing output. So you're going to have an increase in quantity, and they're going to produce more output. And the price, of course, is going to be at that higher price because the price came from the market. That was driven up by that change in demand. B, long-run equilibrium is going to be restored because we started here in long-run equilibrium, producing at the lowest average total cost. So the restoration of that long-run equilibrium will happen as the supply curve shifts to the right to bring it back. And I'm probably going to miss it a little bit here, but if this is our, I missed it completely. Let me try it again. Let's try it again. Let's try it maybe here. Ooh, pretty good, pretty close. So as the supply curve shifts out, because that higher price in the marketplace attracts sellers, and so as sellers see those profits that are being earned by the firms, they enter the marketplace and shift that supply curve to the right, bringing the price back down to where we were in long-run equilibrium. So we would achieve it by supply shifting out or to the right until it's equal to the minimum average total. And again, that takes us back, that market price being the firm's price, takes us back to that long-run equilibrium point. Number 14 lets us take a look at a firm finds that its MR equal to MC output is with these values. Total cost is 1,000, total variable cost is 800, total fixed cost is 200, and total revenue is 900. And so the question is, what should they do? And we can see that at MR equal to MC, all we want to know is what's going on with total variable cost. If marginal revenue is equal to marginal cost, then what they should do is produce, because they're covering their variable cost, they're covering at least their variable cost in their total revenue, right? Because marginal cost is a change in total cost. And they're offsetting their variable costs because they are less than their total costs. And we know that because total fixed cost is 200. So if we did per unit, we could figure that out. But it's an easy thing to see that if our fixed costs are less than our variables, but our total cost is the combination of those two, and total revenue is 900, then they are offsetting at least some of their fixed costs, right? Their total variable costs, 800, are being covered by the 900, and that 900 rather, includes a portion of their fixed costs. So if they're able to offset any portion of their fixed costs, they should continue to produce. So your answer here is they should continue to produce because the loss is less than its total fixed cost. 15, refer to the diagram above. This is the diagram of a perfectly competitive firm. At the profit maximizing output, which is MR equal to MC, total revenue will be what? And so we're going to find that on the graph, MR equals MC, and total revenue is going to be basically price, which is indicated by the marginal revenue curve, times the quantity. So we've got this rectangle here that would be all of the total revenue. So our answer then becomes what you can see here graphically, and that is HE0A. So 0HE, so not in order, but here you go. So that's our look at that. And it's helpful to get comfortable with the graphs, maybe draw them, maybe scribble on them a little bit to see that. But if total revenue is price times quantity, well, here's quantity, output, and here's price. So you just take the area of that rectangle, which can be calculated side by side, price times quantity. Let's see, number 16. The accompanying table gives cost data for a firm that is selling in a purely competitive market. If the market price for the firm's product is $12, which is going to be marginal revenue, then the competitive firm should produce how many? So we're looking for that MR equal to MC. So we've got it right here. We can see it pretty easily that marginal revenue is 12, marginal cost is 12, and 4 units. Now, they ask you for whether there's profit or loss. So here we've got our marginal revenue equal to marginal cost at 4 units. However, what we want to know is, are we covering our average variable? Should we be producing it all? And should we do so? And if so, what would be the loss or the gain? So right away, it's easy to see that at 12 units, the loss minimizing or profit maximizing output would be 4 units. However, the key here is recognizing that the average variable cost is equal to $14.25 per unit. So that is going to be the shutdown rule is going to take effect here, because the shutdown rule says if you can't sell it for at least, if you can't cover at least your average variable cost per unit, then you're better off shutting down, because the total loss in your fixed cost is going to be less than your ongoing loss if you produced at this rate. So it's going to be 0 units at a loss of 100, and that $100 represents the fixed cost, total fixed cost there. Our last one, number 17. Gives us a set of information here. We have our product, our fixed costs, our average variable cost, average total cost, and our marginal cost. It said it gives us data for a firm that is selling in a purely competitive market. If the market price for this firm's product is $87, so marginal revenue is $87, how many will the firm produce? So we're looking for that profit maximizing or loss minimizing output level. So we're going to look for MR equal to MC, and what we can see is right here, marginal revenue exceeds our marginal cost. So that's going to be our balancing point, essentially. So that'd be 9 units. We want to make sure that our average variable costs are covered, which they are, 87 minus 39. And so we're going to produce 9 units, and we can subtract the average total cost from that $87 to get, let me write this correctly, 55.67. 67. And so we're going to produce 9 units at an economic profit of $281.97, because you're multiplying the per unit profit times those 9 units. So that's how you get that one. And I believe we've covered all of them. So my advice is go through this homework, practice it again and again. If you have additional questions, please feel free to ask. And as you're applying these concepts, maybe try the different versions of the problem just to see if maybe you can prove to yourself that you really do have a clear understanding of it. And that always is a good way to go with economics learning, practicing all the time. And I wish you lots of luck.